Okay, let's begin. Welcome. This is a session on visualizing business data on any device with Bing Maps. My name is Ricky Brundrett. I'm on the Bing Maps customer advisory team. Just a little formality here. With all sessions at Build and every other Microsoft conference, we like to gather your feedback. It's very important to us, both for improving our sessions in the future and also as a speaker. It helps me to become a better speaker, and so please fill this out at the end of the session. A quick agenda of the things I'll be going through today. So I'll do a quick overview of Bing as a platform. From there, I'll be going into visualizing data on Bing Maps without writing code. Then we'll talk about different techniques for visualizing business data on Bing Maps. And then finally talking about cross-platform development with Bing Maps using HTML5. So Bing is more than a search engine. There's a whole bunch of developer APIs available today that you can use to start integrating that and adding smart logic to your own application. In fact, Microsoft uses it in nearly every single product today that we have, everything from Cortana to Office to Windows and even Xbox. You can use Bing in a number of different devices and platforms. And not only do we use it internally at Microsoft, but we have a lot of customers out there that use it, as we can see listed here, just a few of them. But you can use it as well, and there's nothing stopping you getting access to those APIs. So going on into the visualization side of things without having to write any code. Just a quick little trivia question here. What percentage of business data is often thought of to have some kind of spatial reference? Any ideas? No? So approximately 80% of all business data they estimate has some kind of spatial relevance or spatial sense to it. You can imagine, all right, you go and you have your customers. Well, every customer has an address for their office or for where their stores are, and so that's just one of many different types of business data. So there's a lot of potential of what you can do with that data when it comes to mapping. One great tool that's available in Excel 2013 is called Power Maps. It allows you to do some really rich, deep analytics of data on a map without having to write a single line of code. You can view your data on either a 2D or a 3D map. That said, the 3D map isn't like what we saw with Windows 10 maps there. It's actually just a globe with no elevations in it. The only elevations you can create would be 3D bar charts. And it kind of makes sense because when you want to analyze your data, you don't really need mountains and buildings unless you're doing something about utilities or something inside of a city. The data can be, in addition to 3D bar charts, there's heat maps in there, clustering. You can view data as administrative boundaries, so polygons for states, countries, and even zip codes in some areas. Another really cool feature is there's the capability to have storyboards and timelines. And I'll show that in a little bit, and that could actually really makes it for a powerful presentation when you need to go through and show data. It's a lot richer than just using a simple PowerPoint. One other really cool thing with the Power Maps is you can actually have custom maps. So you might have situations where, the map of the world isn't exactly what you're interested in. Maybe you're an airport, and you have all the data for where people are walking through and the flow data. Well, why not take a blueprint of your airport, make that your custom map, and turn all that data into a heat map so you can see where the congestion is within your airport. Another really cool thing, so Power Maps is part of the big Power BI stack, but a really cool thing about Power BI is it's not only available through Excel now, it's also available on the web. So you can go through and start creating powerful presentations and powerful reports directly on the web and share them securely without having to write any code as well. So let's jump into a demo here. We'll start off with actually, before we even start off with the demo, just so you know, you guys all have time. You don't have to leave right away I know everyone's in a hurry to get to the airport. We got clear traffic all the way there. But let's jump into a demo here. So we're going to start off with a bunch of data that I found online. So this is the 911 incident reports for Seattle. And so it's a fairly decent data set. It already has latitude and longitude, which kind of makes things a little bit simpler for me. And so if you have Power Maps installed, you simply go to Insert, Map, and launch Power Maps. And hopefully I don't have too many things running in the background. And there we go. So now we get, a simple map. And if we zoom in, we see, maybe I should be using a mouse rather than my finger here. We see a whole bunch of blobs of points, which don't make a whole lot of sense to us. One neat thing is it already automatically identified the latitude and longitude columns, so we didn't have to do anything there. However, if I had a different column I wanted to use as the spatial point of reference, I could set it here. But we'll just leave it as that is. We want to make these blob of points make a little bit more sense. So, maybe let's, take a look at, actually, let's leave it as what we have it set here, but let's add in some data. So if we take a look back at what the table actually looked like, we have this column called Event Clearance Description. So what the different types of events or that 911 situation actually was. So let's find that column, and here we go. And let's turn, there we go. So now that blob of data turns into still somewhat of a blob of data because there's so much of it, but we can see it as a bar chart, and we can actually interact with that. So we can start hovering over pieces of that information and seeing what it is. We can see the different colors for all the different types of incidences or different types of information. And so, this is okay. Depending on the type of data, this might make sense. But, let's do something a little bit more richer. There's other situations where you might, want to create little circles, but this doesn't really work for this data set because it's just too dense. Now, another option here is a heat map. So now this looks pretty cool. So let's close that so we can see this a little bit clearer. And let's change the pitch here so we can see it a little bit better. So, it looks very cool, but we have one issue here. There's so much density in the center of Seattle, we can't really make sense of that either. And, we can't get too much detail. And so there's actually a really easy way to handle that. So if we go to the little settings here, you have all kinds of different settings for the heat map. So we'll change the radius and make it a little bit smaller. So now we can start seeing all the individual locations. And let's go with something like that. And so now we start seeing some key hot spots in that data. And now we know, really where are the hot spots in the city rather than just knowing that downtown has a lot of 911 calls. So another really cool thing, so we can go through here and save the scene. So let's do a new scene. And we'll go back to one of the other data types I had here, or other tables. So we'll go back to that table there with the blob. So now I've changed the data, or the way we're viewing the data. I can quickly click back onto my other scene, and now I have that same view, same data. And even if I go through and I move that and I do another new scene, I can then, come back to this one, and the view recorrects to what it was before. So it's almost like creating a PowerPoint in the sense you have all these different slides, but all the data is interactive. And so you can imagine if you're trying to do a presentation at work, and someone says, "Hey, what's that really big spike in that data?" And you can say, "Oh, well, actually, let's just find out." And you don't actually have to go through and digging through the data; it's just there. The next thing we'll take a look at, so we'll close the directions here, is if you go to powerbi.com and you sign in, and there we go, I'll just sign in quickly. We can then start doing, creating, oh, great. I didn't bring my smart card. Well, we're going to have to scratch that demo. You can actually go into Power BI, upload an Excel spreadsheet, but it's not limited to Excel. You can tap into other sources of data, so you can connect up to a database. If you have data in a CSV format or another format, you can upload it that way. You can point it to a file that's on OneDrive or one of the other cloud storage services, and it'll automatically pull that in, and then you can start building your reports, which are very similar to the pivot charts and pivot tables that you would have inside of Excel, but all available inside of a web browser and can be shared with your colleagues in a secure manner, so the data isn't shared with the world, but only with the people you want to share it with. So we'll jump back to the slide deck here. So, Power Maps, Power BI is just some of the ways where Big Maps is available where you can start visualizing data without having to write any code. There's a lot of other tools available today. So Power View is also built into a number of different platforms. So it's in Excel 2013, it's in SharePoint 2013, and it's part of Power BI. It's actually the same kind of maps that you can get in the web version of Power BI as well, which is the 2D map where you can do little circles for the data, or you can even create polygons for the data as well for the regions. Dynamic CRM also has some map integration in it, and the different versions of Dynamic CRM. SharePoint 2013, again, there's some additional functionality other than Power View that also allows you to map data without writing any code. And then probably one of the first places where we set it up where you could upload data and view data on a map without having to write any code is SQL reporting services. Back in 2008, R2, we made that available, and it's a very common feature that people use. And for pretty much all of these, there might be one or two versions of some of these platforms where all the mapping functionality, being that it's built into those different pieces of software or those different products, there's no licensing required. It's just there and made available to you. For the Power BI stuff, you definitely need the Power BI license, but then you get access to Power Maps and all the other tools that are in Power BI. All right, moving on, we're going to take a look at visualizing business intelligence data on Big Maps and some very common techniques for doing that. We'll start off with the basics: Pushpins, Polylines, and Polygons. Probably the number one use of maps today is putting a single pushpin on a map. And you go through all the different apps on all your mobile devices or on your tablets, and you'll find that probably 9 out of 10 times there's a map with one pin on it, and that's about it. That said, when it comes to business data, it changes drastically. People want to visualize a lot more interesting data, and you can do that very simply with polylines and polygons. Now, when it comes to visualizing that data using these different shapes, there's some cool different techniques you can use to make sense or make better sense of that data. So, having a simple icon is nice, but you might want to have different types of icons or custom icons that are unique to a situation. So if you're showing your customers on a map, you could show the logo of their company on the map instead of just a generic pushpin on the map. That way there you can look at the map and you instantly know, okay, that's who that customer is. I don't even have to click on the pushpin to find out. The size of an icon can make sense here. So here in the screenshot, we have some circles that are all scaled based on the size of the data that I've passed in, or some metric of that data. And we have documentation on how to do that very easily in Big Maps. And then, of course, there's also the color of the icon and the shape of the icon. So I mentioned before, you can do the logos, but if, let's say, some common KPI UI stuff that's used in other things other than maps is often used like squares, triangles, and circles, and then also using the colors green, yellow, and red. Of course, you can use any color in any shape that you want, but those are just some common examples. Another thing that a lot of people aren't aware of is you can actually change the line style. So you might, if you're drawing a polyline or a polygon, you might have a situation where, let's say you're drawing utility lines on a map. Well, if all the utility lines are for all the utility lines that are above ground, you might want to draw them as a solid line. But if there's some lines that are underground, it might make sense to show them as a dashed line. That way there you can identify the difference just by visually looking at it and know, okay, I don't need a ladder to go work on that line. I need to bring a shovel. When starting with pushpins, it's great, to visualize data, but if you start visualizing too many pushpins, it gets really cluttered. And so we take a look on the map there on the left, and I think I have about well over 1,000 pushpins on the map. You can imagine the more pushpins you put on, the less of the map you see, and eventually, it just doesn't make sense having the map there because you're not making any sense of the data. One way to kind of take care of that is to use what's called Pushpin clustering, which then does a quick analysis of the data on the map in real time and says, okay, these 3 pins are overlapping or very close to each other. Let's group them together and make them a cluster, and let's uniquely identify them. So on the image on the right, all the red circles are the clusters, but if you look closer, you'll still see a couple blue circles in there, and those are ones that didn't fall within an existing cluster. So as you zoom in, these clusters start breaking apart and you start seeing more and more pushpins, but only for the area you're looking in. And so it makes it a lot easier to navigate through the data, and it also allows you to render a lot more data on the map. So instead of hitting performance issues with JavaScript, once you get up around 5,000 pushpins, you can start rendering tens to hundreds of thousands of pushpins on the map. And if you if you take it even a step further and start doing all the algorithms on the server side or in the database, I've seen examples where they've done it with hundreds of millions of pushpins. Density heat maps is kind of similar to the idea of clustering, where you start grouping data and then uniquely identifying it based on the density of the data or closely related pushpins. The way the heat maps work here is you start taking every data point, give it a little gradient circle, and as those circles overlap, they start creating darker and darker areas. We then map that gradient color or that transparency of that gradient to another color gradient. And then that generates that nice heat map like that. And so clustering, heat maps, we have all kinds of source code available where you can actually get that functionality into Bing Maps with only 2 or 3 lines of code in the most simplest version. Of course, there's tons of customizations. You might want to change the color, change the intensity and stuff like that. And all that's available in there. Of course, the more customized you make it, the more lines of code you'll need. But the simplest example, 2-3 lines of code and you're good to go. Data binning is a fairly, it's been around for a while, but it's something I haven't really seen used too often until recently. And it's a pretty interesting idea. Again, it's similar to clustering, it's similar to heat maps, but what it does is it breaks the map up into evenly spaced or evenly fitted geometric shapes. So you might use a square, triangles, or hexagons, like we see in these examples here, where all these shapes fit in all together nicely. But spatially, they're not really. It's not a zip code. It's not a city, but it's an evenly sized area. And then based on that, we then find out all the data points that are inside of that, and then change the color based on either some kind of metric or the number of points in there. A really good example I've seen of this. There's a real estate site in the UK that I've worked with, and they did this for every single property in the UK. And they changed the color based on the the last sold price of that property. So now you have, rather than trying to show, like a push pin for each property and coloring that push pin, you have this map of squares that kind of fits together really nicely, or it does fit together really nicely. And you can see this heat map basically, but it's a little bit more in depth than the gradient heat map or the density-based heat map that we just saw before. Going a step further, another type of visualization that a lot of people like to do is thematic mapping. Now, this type of mapping has been around for ages and is probably one of the most common ways of visualizing data and sharing data from a business sense. A lot of people, when they think of thematic mapping, who are familiar with that term, or this is often confused as heat mapping, is they think of maybe, okay, all the country boundaries or all the countries color-coded based on some kind of, metric. It could be like, census data or some other information. It could be the population. And very similar to the image we see there in the bottom right. But another type of thematic map, it doesn't necessarily have to be a polygon. You can start using polylines. So a great example of that is the traffic data inside of Bing Maps, where, the actual data is the road, and we change the color of the road based on the flow of traffic. Or could be any kind of metric, if we wanted to know the number of cars, for instance, or something like that. One quick tip, if you do start doing kind of mapping like this, as you zoom out, make sure you focus on larger areas. As you zoom in, you can then start breaking into smaller areas. So this screenshot here at the bottom right with we're actually visualizing the unemployment rates in the US. Based on each county in the U.S. So it's a massive, data set. And at this zoom level, it looks all right, but you can imagine, you can't really see the smaller polygons on the East Coast. So maybe at this level here, it might have made better sense if we were visualizing this as a state, at the state boundaries rather than the county boundaries. And if I zoomed in a couple levels, then start showing the county data. One benefit of doing that as well is by limiting the view when you're looking at higher or density data, is it reduces the amount of data you actually have to load. So you get better performance. So let's jump into some more demos here. Okay. Okay, we're done with this. We'll close these up. Don't save. And so we got client-side clustering here. So this is just a really basic example. So let's throw 5,000 pushpins on the map. And there we go. What I've done here is we have a little plus sign on top of the default pushpin to indicate that it's a cluster. Well, I didn't want to click on it. I wanted to zoom in. So now let's zoom in. And we see the cluster start breaking apart. We can start seeing some that aren't clusters. We just see the individual pins. So if we click on one, we see, okay, this is a single location. If we click on a cluster, we see, okay, this is a cluster. Well, let's try one that's in view. That's a cluster. And there's 77, or no, that's the grid size, but there's 5 other pushpins in that cluster. And if we zoom in, we can start seeing more detail. So let's zoom in some more. And it starts breaking apart here, and we can get a lot more data. So you can imagine if you're visualizing a lot of data, this is a lot easier way to go through and navigate that data. Now, let's take a look at the heat map one. So again, we'll do a little bit larger data set. Let's go with the 25,000, and we'll update the heat map. Yeah, maybe let's go a little bit bigger here. Let's go 50,000. Okay, so now we got lots of data on the map as a heat map. And we can go through and change all kinds of different settings with that data. But this is all based on the number of points that are overlapping, and it creates a nice gradient. We can change the radius, very similar to the Excel demo I did earlier. We can change the radius of each single data point so that it uploads or updates the map accordingly. And there, okay, let's try a smaller radius. Oh, I gotta press update. And, okay, that's too small. Let's try that again. There we go. So now we got a smaller heat map or density map. And so if we zoom in a bit here, we can then start seeing it a little bit clearer. And, this might make a little bit more sense. And so the radius of your data for when you're doing your heat mapping would really vary depending on the type of data you're visualizing. So if you're doing heat map based off of, cities, you're going to need radiuses that are at least the size of the city. But if you're doing, heat maps based off of individual incidences, like the 911 incidences we were looking at, you only need a small circle for that because that's a small area. We can change some other things like the intensity of it, but we won't worry about that. But we can also change the color. So instead of having the green, yellow, and red there, we can change it to something so it looks like it's on a little bit hotter type thing. And there's a number of other options for that as well. So the next thing I want to show. So this is a nice little example here with a thematic map that's nice and interactive, and it's all rendered in JavaScript. Has anyone here heard of D3.js? Yeah, okay, I see a few hands. So for those not familiar with that, it's a data-driven JavaScript library for visualizing and rendering nice UI on maps, or not maps, on web pages. So it could be charts and a number of other things. But it makes it very easy to visualize data and make it data-bounded. And so a while ago, well, I say a while ago, a couple months ago, I made a module for integrating that with Bing Maps so that as I pan and I zoom, all the data stays within the right location on the map. But if we take a quick look at the source code, so I have some styles here, but if we skip that, here's the whole source code. So it's fairly short. I got I load up the map. Actually, let's jump into Visual Studio because I have it zoomed in there. And here we go. And actually, here's a really simple version. So we load up the map here initially. And then after we do that, we load in the register and load the D3 module for Bing Maps. And then once we go to do that, we then create a D3 layer for the map. And then we specify where our data is. So I'm using a data type called topo.json, which is a fairly new data type. If you've worked with spatial files before, there's a common one called GeoJSON, which is a way of storing JSON or spatial data as JSON. And topo.json is basically a compressed version of that makes it a little bit, or makes it significantly smaller. So a 2 megabyte file turns into about a 200 kilobyte file. And so I'm using that just for performance reason for the loading. But then I'm able to pull that data in, and once that data is pulled in, it's basically just using SVG to to then render that data on the map. And the map itself, or the module itself, actually takes care of the updating of the data on the map so that it's always positioned in the correct place. If we take a look at the literacy one, which I was showing, it's a little bit more advanced because now I'm pulling in two files. So I'm pulling in both a topo.json file for the county data and for the states, but I'm also pulling in a tab-spaced file that has all the literacy data. And so I'm then merging that data together and then rendering it on the map. So I also have a little bit of code here for a little legend there. But if we just focus on the code that was used to render that map, we're looking at maybe 20, 25 lines of code total, which, if you tried to create a heat map like that in the past, it could have taken you quite a long time. And it works very well. The example or the screenshot I showed earlier with the county data, visualizing county data on a map is very hard, especially when you're working with JavaScript, just because there's so much data. All right. So I mentioned a lot of these, the modules, like the clustering, the heat map, and the D3 modules. There's a lot of modules built into Bing Maps, but there's also a lot, let's zoom in here, available online. So we have a pretty big developer community around Bing Maps. And over the years, we've been developing modules, or basically we built something really cool. We want to make it reusable, so we turn it into a module so they can be added in very easily. So I've created a number of modules, but there's a lot of other modules here that have been created by some of our Bing Maps MVPs. So things from like drawing tools, clustering, heat maps, and being able to actually another interesting one at the bottom is well-known text. If you've worked with any of the spatial data on SQL Server, well-known text is a way to represent spatial data as a string. And so there's a module that allows you to easily take that string, visualize it on Bing Maps, take the data on Bing Maps, and turn it into a string. That way there you can easily take that data from SQL Server and connect it up to Bing Maps and have it in your own custom application. All right, so let's jump back to the slide deck. All right, trivia question number 2. How big would a single JPEG of the world be at zoom level 19? So at zoom level 19, we got 30 centimeter resolution imagery. So anyone got a guess? No? It's really big. The image would be, hundreds of millions pixels or square pixels in size, or actually probably a lot more than that. But it's a massive image. Just the road map would be, or an image of just the road data would be well over 200 terabytes, and the aerial imagery would be over or close to a half a petabyte, if not more. And that's just the flat 2D maps. You can imagine the maps that we have now in Windows 10 with the 3D data, how much bigger that data gets. But we were using Bing Maps today in JavaScript, and we have been for a long time. So how do we actually get that much data visualized on a map? And so that brings us to tile layers, which is another really common way of visualizing data on maps. And it allows you to visualize large data sets as well. The basic idea is we take this giant image and we cut it up into a bunch of even-sized squares, which are 256 pixels by 256 pixels for Bing Maps and most other major mapping providers. And then we give them all a unique naming convention. So we use what's called a quad key naming convention. So the idea here, if you take a look at level 1, the top left image is, we give it 0. Then the next one's 1, 2, 3. If you zoom into the next level, let's say if we zoom into the the area of tile 2, we keep that number 2 ID, and then we start doing the 0, 1, 2, 3 again, and keep appending that on, and we end up creating this unique string that points to that exact tile. Another common method is using what's called XYZ. So we might say, okay, it's 3 tiles to the right, 4 tiles or down, and then zoom level 10. And that would basically, it just means you're storing 3 variables instead of 1, but at the end of the day, it takes you to the exact same data. And that can all be done with Bing Maps. Another method that's used sometimes is bounding boxes, where people say, okay, my tile is within this square of coordinates, and then load that up. And that, again, can also be visualized on Bing Maps very easily. Now, there's a couple different types of tile layers. There's static tile layers and dynamic tile layers. Static ones is basically, let's say I have an image of a floor, the blueprint for a mall. And I want to visualize that on top of Bing Maps and make it so I can zoom in, zoom out, and pan. And so what static tiles, since that data isn't really changing, static tiles is a great approach for that. And basically, there's a lot of different ways to go about this, but one great tool is called Microsoft Map Cruncher, and it allows you to load up either an image or a PDF file and cross-reference a minimum of 3 data points on your image to physical points on the map. So if you do the 4 corners of the building is usually a pretty good way to go. And then you press a single button for create or mash up your tiles, and it actually goes through and generates all these images for you, which match our naming conventions for our maps. You then just upload these up to your web server and access them just like any other image. But in this case here, if you're adding it to Bing Maps, you just pass a URL to where they're stored, and the map control will go through and request them as needed. So extremely simple to do. You don't need to write a whole lot of code to do it. Actually, the code to load in a tile layer, again, is about 2 lines of code, one to create the tile layer and one to add it to the map. But one of the downsides to this approach is it's very hard to maintain. You can imagine, okay, the blueprint's changed, so now I got to go through, do this cross-referencing again, and re-upload and change the data. So, pros and cons to that approach. You're trading simplicity for a little bit harder management. The other type here, dynamic tile layers, is ideal for when you have constantly changing data or really big data sets. The storage limitations on static data. So if you're doing, instead of looking at a mall, let's say we're looking at the whole world. We just saw a single image of Big Maps is 500 terabytes. If you did the whole world, but you can imagine trying to store all that data on your web server just isn't manageable. So what you can do is you can actually cut that image on the fly using a web service, or you can even take your data from, say, SQL Server and render it on the fly as a tile and overlay that on top of the map. So it's a little bit more complicated in terms of the architecture, but we actually have all the source code available. If you download one of our demos for it, you can actually change it to point to one of your data sets, and if you have the right column name for the spatial data in your database, or update the code to point to the same name, you'll be able to get it on the map in about 10 minutes or less and start visualizing large data sets. I gave a presentation 2 months ago on visualizing big data. One of my partners used the exact same technique. They were visualizing 500,000 complex polygons on the map, and the data set was about 64 gigabytes. So, visualizing 64 gigabytes of raw data on the map and being able to interact with it as well. So, tile layers, even though it's an image on the map, being that your data is stored in a spatial database, you can actually find out what people have clicked on by doing a quick request against the database. So it's very useful for constantly changing and large data sets. So here's an idea of what a typical architecture for that might look like. So you store your data, your vector data somewhere, or your spatial data somewhere. So SQL Azure is a great place for that. Another great place, if you're using Big Maps, is Big Maps Spatial Data Services. The Spatial Data Services is essentially a wrapper around a single table inside of SQL Azure, and it exposes that table as a spatial REST service. So you can imagine, okay, you've uploaded maybe a CSV file or something like that to a database table, and now you have to go through and write all that kind of code to expose it, to do a find nearby, so I want to do a radius search and stuff like that. The Spatial Data Services takes away all that complexity. You basically upload your file, and now you have a REST service, and the REST services can allow you to do nearby searches along a route within a polygon. You can do even complex, we now added support for complex data types, so you can start doing intersection tests. So now I've got all my boundaries for all my sales regions. Show me all the boundaries that the user just drew out, all the ones that intersect with that. From there, we have a simple service inside of Azure that we can then take that data and render it as a tile, and we have all that code available, and there's a lot of partners that have solutions for that as well. And one nice thing to do is also to cache the data if it's not changing that frequently. If it is changing frequently, sometimes you can still get away with a 1 minute or a 5 minute cache, and that can make a huge difference if you have a lot of users. So using something like the blob storage is a great simple way to do that. The example I'll be doing here is just using the local storage, but we do have code samples that do it in blob storage. And then finally, we take all that data, we overlay that service over top the map as a tile layer using that 2 lines of code I mentioned, and we get a map that looks something like that. So let's take a look at that right now. Okay, so let's see, King County map. So here's the a project that we put together. This code sample is part of a white paper. So we have a white paper we just put together that goes step by step of how to do this and a lot more. And we show how to do it both with SQL Server and also with the Bing Spatial Data Services and using local cache and Azure cache and things like that. So if we take a quick look at the SQL Server approach or service, basically all we have to do is specify where we want to have the cache, and it goes through. And actually, let's zoom in a little bit here. So we go through here, and we just scroll down here. So we go through, we do a little bit of math here. So we use the Bing Maps tile system to figure out what tile they actually requested and figure out what data is in that tile. So we basically calculate the bounding box of that tile and say, give me all the data in that bounding box. And then we have a little tool here that allows us to render all this data, a SQL geometry or a SQL spatial type, on an image using a system.drawing. So if we scroll down here, we'll take a quick look at a polygon, and we basically go through and we basically just create an array of pointf objects and pass it to a graphics path in system.drawing and render it on top of an image. So seeing that in action, we'll jump back over here. So I've already loaded it up, and so recently I was in the market for buying a new house. I just moved from the UK to the US, and one of the things I was interested in doing was finding out, okay, where are the property boundaries of these houses I'm looking at? And so this property boundary data is often called or is known as parcel data. And there's a couple of real estate sites that do show you that data, but I found that they often limit the zoom level you can go to. So I can see the property boundary of just that house, but I can't really see the neighborhood that well. And so in this example here, we're now storing all that data up in the spatial data services of Bing Maps, and then taking that down, rendering it as a tile, and overlaying it on the map. And so I'll change the style here so you can see a little bit clearer with the aerial imagery. And so now we have all these different polygons. I can zoom around, and I can start seeing the neighborhood and all the property boundaries for everyone in the area. And so this data set I have here is for King County in Washington. It's about 400 megabytes in size, and I'm able to navigate on it or around it very easily. And we can start zooming out and start seeing quite large areas of all the properties. Of course, the further you zoom out, the harder it gets to see in some areas because such small areas or small properties in some areas. And then as we zoom in, we can start seeing more and more data. And there we go. So from there, we're going to go back to the slide deck and move on to our next topic, which is using Bing Maps and cross-platform apps using HTML5. So when it comes to using Bing Maps and cross-platform apps, there's a lot of different approaches. You can use native .NET code, and it's great for good performance and if you need offline maps. But we're kind of limited at the moment to what platforms that's available to. So we have offline maps available in Windows Store apps and Windows Phone. So you can do this for Windows Phone 8.1. You can have offline maps and any Windows 10 apps for phone and both and PC. Hybrid apps using JavaScript and HTML is a nice approach where not only can you target all the different mobile browsers out there, you can target all the PC browsers and pretty much any other device that can render a web page. One possible downside is if you're on a slow wireless connection, it could be a little bit slow loading the data because you can't store it locally, or you can't download the maps offline. And so you got to make all these requests for the map images so that there's a trade-off there for simplicity, for performance. But if you're just doing a single pushpin on a map, it's pretty straightforward and pretty easy to do. One thing that a lot of people overlook is another approach is to actually use web services. You may have a situation where you don't actually need an interactive map. Maybe you just need an image of a map, or maybe you want to do some kind of spatial calculation. So a great example is Cortana. Have you ever, you set up a meeting, you put in the location field for the office location that you're going to have it, or the building you're going to have your meeting, and then an hour before or half hour before, Cortana tells you, oh, you need to start heading to your meeting now because with the current traffic conditions, you'll just make it, and it shows you a little map with the route on it. Well, all that's using Bing Maps on the back end. The image of the map, of course, is coming from our imagery service, and it's just a static image. But the calculation of the travel time is just using our routing service. And so using something as simple as calculating directions from point A to point B, if you do a simple calculation ahead of time and say, okay, well, if the meeting is an hour away usually, so let's an hour and a half before do a routing calculation and see what kind of time it is with current traffic conditions. And then tell the user, okay, time to go now, or hey, you got another 10 minutes, then you got to start going. And that's what Cortana is doing in the back end, and it's basically just using our existing services for doing that. So one thing, so as I said before, we're going to focus on mainly the HTML5 stuff. However, I highly recommend taking a look at session 757, which was the Universal Windows apps or maps in apps session that was presented on Wednesday. And it's a great way to get an introduction to the new maps in Windows 10 and all the 3D capabilities that are in there and the offline maps as well. So hybrid apps using HTML5 and JavaScript, we heard a lot about that at the conference this week, and it has been around for quite a while. And the general idea is you write once and you use it everywhere. And so there's a lot of different development paths you can take to get to that, to do this. Probably the core method would be to you create a mobile website, and now go through and create an individual app for each platform that then uses the web browser control or the web view control, depending on the platform, and just loads your web page or your map app inside of there. That's a good approach if you already have an existing app that's already written for an individual platform. But if you're starting from scratch, you might want to use something like Apache Cordova, which we've seen a lot today, especially with all the new functionality inside of Visual Studio 2015 and it being built in there, and it makes it a lot easier. But another approach as well, if you're creating a Xamarin-based app, you can easily use what's called the hybrid web view control, which is available on Git, and do the exact same thing that we've seen here, but with the other two approaches, to take your HTML5 map and load it very easily into your Xamarin app. That said, for Xamarin, another interesting thing is on Monday I sat in one of the other cross-platform apps, and someone did a little experiment, and they actually created a wrapper around one of our native controls to actually work in Xamarin as well. So once I get a little bit more information on that, I'll be sure to share that on our blog. A couple tips when you do use the HTML5 JavaScript controls for Bing Maps, especially when you're targeting cross-platform, is to enable high DPI functionality inside the map. So there's a one-line piece of code where you say use the high DPI maps. That way, there when you're using like a mobile screen which has high pixel density, you get the higher quality maps that that have bigger labels, so they're easier to read. Otherwise, you end up with the small labels and you can't really see them that well. The cool thing about enabling that is the map control is smart enough to know if it's not on a high pixel density screen, and it automatically will go back to the standard maps. So that way there, if you are using, let's say, a desktop that doesn't have a high density screen, you don't end up with these massive labels on the map. It's all comes back and is a relative experience. Another useful tip, so if you try to access an external JavaScript file or that's hosted on the web in a Windows Windows Store app or a Windows 8 app, you'll likely end up with some headaches with security issues. The reason for that is it's just part of the architecture of Windows 8. It doesn't allow you to call in external files very easily. There is some workarounds for that. However, there's a very easy way to get around that with Bing Maps. We have an SDK for Windows 8 that works in JavaScript. It's about 99.9% identical to our web control. There's only one difference in there, and it's so minor that I'm not even going to bother going into to explaining it. So if you actually install that into your Apache Cordova app, you can then simply just update the script reference for when you go to deploy your Windows Store app, and it'll use that local copy of Bing Maps. Now, another great benefit of doing that is, being that it's local, you end up getting the bytecode caching, which means it's going to load a lot faster because it doesn't have to call out to the web to grab that map control. So simple, architecture of how an Apache Cordova app would work with Bing Maps. You have your Cordova app, with your HTML and JavaScript. You simply just push in Bing Maps and then load it on the map. Xamarin app is a little bit different, the approach I was mentioning there earlier. We can use the hybrid web view control and then pass that into a C# app inside of Xamarin. So yeah, the session I was talking about with the native wrapper around for Xamarin was session 627, so you might want to check that one out as well. I'm already in contact with the speaker to see if I can get a copy of their code. So let's take a look at some code samples here and some demos. All right, so first thing I wanted to start off with is the Bing Maps Interactive SDK. If you're developing an app using Bing Maps in JavaScript, this is a great place to start. So if we go in here, let's say we want to load a map, it gives us the code we need to load that map. If we want to make a couple changes, let's say we want to add a pushpin, let's add the default pushpin, and we see how easy it is to add a pushpin to the map. So let's go through and create a basic Cordova app. And let's get out of here. And well, let's see, actually that's a good name. So as that loads up, what we're going to do here is let's find one that, actually, yeah, this pushpin one looks good. So let's press the View HTML button, and it gives us all the HTML that makes up that map view. And we'll just copy and paste this over to our app. So let's close that. So we'll just open up the index file. There we go. Let's set the zoom. All right, so now we've added in our map. It's very simple, and we got all it does is load up a map control and then add a pushpin to it. And actually, let's get rid of this function here so we don't have to press a button. We'll just get rid of that button. And then if we deploy that app, we'll see Bing Maps inside the Android emulator, or oh yeah, I'm using the emulator that's inside of Google Chrome. So it'll deploy it to there so we can start seeing the map loaded up very easily. All right, it's taking a bit longer. So as that loads, I'll talk about another code sample I have. So a while ago, I was doing several years ago, we had people who wanted to do cross-platform development with Bing Maps, and they were using HTML5. And so I downloaded the code samples we had on MSDN, and just for fun, I tossed them into an Apache Cordova app. And so we'll come back to that in a second. I just tossed them into an Apache Cordova app, and it just worked. So this one here is the demo. So this was an app that was created several years ago. Didn't make any code changes, simply just dropped the code into an Apache Cordova app inside of Visual Studios. And now we have this map here that we can zoom in, has a bunch of different buttons so we can do, let's view some traffic on top of the map. And of course it doesn't want to work when I'm doing it. All right. But in any case, I took this old app, and it's just worked. I didn't have to do any changes to it. So it's something that we have done before. Now, going back to the other demo that we're starting to put together. All right, we got our map with our pushpin on it, but we see a couple issues here. First one is, we got this little message across the map saying that you have some issues with credentials, this, that, and the other thing. Another issue we have is the map is pretty small. We want it to fill the whole screen. And maybe that navigation bar, we don't really need the zoom buttons, we don't need the pan buttons, we just want to see the drop down for changing the map view. So let's go back to our code sample here. And, oh great. Come on. All right, there we go. So now we're back. Oh, that's the old one. All right, let's close that. All right. Let's go to my backup here. All right, it's real 2013, doesn't matter. So this one here, now, this is basically almost the same app, but I made a few key changes. The first change is right here at the very top. And what I've done is I've added the viewport information. That way there, that when my web app will take up the full screen. The next thing I've done is, I've added my credentials to get rid of that error message across the screen, and then I've changed some settings. The first one is I enabled high DPI and set that to true. That way there I get the higher resolution tiles when I'm using a high pixel density screen. And then I've changed the navigation bar and the scale bar. Like, we don't need the scale bar on the map because it takes up some room. We don't need the dashboard. We only want the little drop down, and a couple other different settings that I've changed as well. But we still end up just adding a simple pushpin to the map. One other difference between this code and the other code is I got rid of all the style settings because we want the map to take up the full thing. I don't want to limit it to a certain pixel size. So now if we run that sample, I should have got the latest version of Visual Studio. It's a little bit faster with this part. Oh. What's that? Yeah. So as this loads up here, a couple of key things or a couple of cool things to check out. If you haven't already, go check out the Bing booth on this third floor. All right, let's kill that and reload. On the third floor. We've been there for the last couple of days. We've had a lot of people come by. We want to hear from you, get your feedback. Another cool thing to check out, if you go to binglistens.uservoice.com, you can provide feedback on all of our different Bing products, whether it's Bing Maps or any of the other Bing Maps APIs. And we want to hear what your ideas are, what your features are, what you'd love to have. All right, now why isn't this loading? All right, let's try this again. Okay. There we go. So now we got our map. It takes up the full screen. No more error message. Oh, actually, I got rid of the drop down as well. But we can go through, we can pan, zoom the map, and it looks very nice. Because I'm doing this on my laptop and not on an actual device, it's not using the high pixel density tiles because it doesn't need it for this screen. But if I was using a mobile device, it would change the tile sets so the labels were a little bit bigger. So very simple to get started. Anyone can do this. Like the initial example I showed you had about 4 lines of JavaScript and one real main line of HTML. But you can do this yourself and get started today. All right, so let's go back to the PowerPoint here. And we got trivia question number 3. What new online Microsoft tool can you use to visualize your data on a map without having to write code? Any ideas? Were you guys paying attention at the beginning? No? All right, the Microsoft Power BI public preview. So if you go to powerbi.com, you can give that a try either today or when you're at work next week, and easily upload and visualize your data on top of a map. So now we get to the call of actions from the session here. First one, of course, try out Power BI and try visualizing your data on a map without writing code. I don't know about you, but I often get a situation where a customer just wants to see their data on a map. They don't need it to be a custom app. They just want to see what it looks like, and that's a great way to do that. Use Bing Maps in your apps. We got a lot of different APIs, a lot of different tools, and so we can help you out with that. Check out session 757, as I said, to learn more about the maps in Windows 10. And follow us on Twitter at Bing Maps. I monitor that along with a number of other people on our team. So if you got any kind of feedback, pain points, or if you just love us, send us a tweet, and we'd love to hear from you. And also check out the blogs.bing.com/maps, where you can go stay up to date on what's new with Bing Maps. So we make all our announcements there. We do about 2 to 3 blog posts a week. We also do a lot of technical blogs on there as well. So if you want to figure out how to do all this cross-platform stuff with Apache Cordova, we have a couple blog posts on that on there. Same thing with the dynamic tile layers, and actually everything I've shown here we have blog posts for. But you can also use the comments there to reach out to us if you don't use Twitter. You can also reach us on the forums. So if you use MSDN forums or Stack Overflow, either go to the Bing Maps forums in MSDN or tag your Stack Overflow posts with Bing Maps or Bing-Maps. And we'll be sure to see it and help you out, whether it be a simple question or if you need an in-depth information about Bing Maps or or possibly want us to come and talk to your company more about what Bing Maps can do. So with that, clicker stop. With that, thank you for attending this session. Please, go through, do your evaluations, and be gentle. All right. So thank you very much.